For the last month or so, I've been doing an internship in prompt engineering. I've read state-of-the-art papers and worked on a number of products. And I've also had the pleasure to talk to and even beta test for some startup teams working in natural language and prompt engineering space. So today I will share some of my thoughts on this young and rapidly growing field and basically answer some of the questions that I personally had 2 months ago that I've more or less learned the answers to. And a quick disclaimer before I start. While I learned a lot in the past months, I still know very, very, very little. And what I have to say only represent my own opinion. And it is definitely the opinion of an amateur. So take what I have to say with the largest grain of salt you can find. First question, what is prompt engineering? I will assume you already know at this point what ChatGPT is. And simply put, prompt engineering is the study of how to talk to ChatGPT and use ChatGPT to get the best result for whatever task that you're trying to accomplish. And now this is a perfectly accurate explanation, but it is not very informative. It doesn't really capture the relationship prompt engineering has with past machine learning, natural language processing paradigms. And specifically, it doesn't capture the evolution from training your neural network from the ground up to transfer learning or fine tuning and to now prompt engineering. And I will try to elaborate on this a little bit more with an analogy. Say you are a football coach and you need a new player. At first, there's no real better way than finding someone off the street and training them from the very beginning. Other than teaching them how to play football and specifically teaching them how to play football in a way that you want, you first need to train them to be an athlete, right? You need to train them to run, to jump, to lift weights, and to just work on general fitness. And obviously, this is insanely expensive, right? You need a lot of equipment, you need to devote a lot of time. And the worst part is you're not really guaranteed any results, right? Maybe the person you found isn't cut out to be an athlete. So this is analogous to training your own neural network from the ground up for a specific natural language task like text summarization. It takes a lot of GPUs and it takes millions, if not more, data points. And it takes a lot of time. And moreover, you're not really guaranteed good performance. Then came large, flexible, and publicly available transformer models like BERT and GPT-3. They are general models that can be repurposed with some fine-tuning to any natural language tasks. So instead of picking someone off the street, you're basically picking an athlete. You're going to your local gym and you find someone who seems to be built for football. Now, all you have to do is make a copy of them, which in tech is pretty easy, and then train them to play football, and specifically in a way that you want them to play. You don't need to worry about their fitness as much because they're already, hit the gym. They're already athletes, essentially, and they're already in fairly good shape. This requires significantly less resources and significantly less time, and the result is fairly reliable. They're, athletes. Maybe they won't be good at football, but, the chance of that is much lower than picking someone random off the street. And this is analogous to the method of fine-tuning existing models like BERT or GPTs. And you need, somewhere between 100 to 100,000 data points, and you need some GPUs probably, but compared to training from the ground up, it is much, much, much more efficient and cheaper. But then came ChatGPT, which is analogous to having this extremely talented and well-conditioned athlete who already knows how to play every sport pretty well. Like imagine Michael Jordan if he was actually good at baseball and every other sport, including football. Since they're already in great shape and knows how to play football, all you really need to do to get them started is to tell them, play football. And they will do so reasonably well. And prompt engineering is essentially the study of how to get this incredibly athlete to play football in the way that you want. And instead of focusing on training the athlete's fitness level or teaching them how to play football, you get to focus on how you want them to play. And it is like you went from like an academy level coach who's more focused on training fundamentals to a professional coach who's more, concerned with play style, tactics, and, performance optimization. And you can give, precise instructions like, play left wing, or show some videos of the kind of football you want them to play. And this is analogous to writing good prompts to ChatGPT and giving examples, or as pros like to call it, few shot learning. There are, of course, a lot more advanced techniques like retrieval, multi-agent querying, React architecture. The list goes on. But the key idea is to take advantage of the general abilities of ChatGPT, so that compared to fine-tuning, you can even use even less resources and only have to do like the very last bit of the work. Next, do you need to know how to code to do prompt engineering? The answer is no, but yes, but also not really. No, because you can do a lot with just typing into ChatGPT. And in fact, even if you do have more complex techniques in your bag, this is almost always the best place to start. And there are also a lot of tools out there, like Bing AI Chatbot, that extends the power of ChatGPT by giving it tools like browser access. However, it is similar to building web applications. Sure, there are no-code platforms out there like Wix that can help you build quick websites. If you want to customize, if you want to optimize performance, then you will need to learn how to code. And it is the same with prompt engineering. If you want to truly fully leverage the power of ChatGPT, then you will need to learn how to code. However, it is worth noting that compared to other forms of machine learning, prompt engineering is incredibly easy from a technical perspective. You don't need to know uni-level linear algebra, calculus, probability theory. You also don't need to know any complex algorithms or architectures. All you really need to know is how to write simple Python codes, and also a framework like LangChain, which admittedly isn't the best documented, and that can make things a little bit difficult. But since I firmly believe anyone can pick up Python in an hour or two, I think you can realistically start doing state-of-the-art prompt engineering tasks within like a week, even if you don't know how to code at the beginning. In fact, I would say, as crazy as it may sound, projects like building a chatbot these days is not a bad first project for someone learning how to code. And if you want a tutorial on how to do this, leave a comment down below. If there are 5 or more comments, then I will make a video on this. Moving on, what are the strengths and weaknesses of prompt engineering and LLMs in general? Essentially, the question is, what can be achieved with LLMs through prompt engineering and what remains difficult? What I learned about this definitely surprised me. A quick summary would be, LLMs are awful at quantitative logical deduction, decent and potentially amazing at textual data analysis and reasoning, pretty solid at CoGeneration, and incredible at my personal favorite use case, and that is text data processing. I will dive into details for each of them. So starting with LLM and quantitative logical deduction, I really thought LLMs would be better at these. I always thought, under the influence of sci-fi admittedly, that AI or LLMs would be better at quantitative tasks. This is also at least somewhat consistent with history. Hallmarks for AI, from my perspective, at least as an average bystander, are things like Deep Blue and AlphaGo, which defeated humans in logical games that are strongly associated with quantitative reasoning skills. However, it is certainly not the case for LLMs. One of the teams that I talked to is working on quantitative interview simulations, and they had a lot of trouble with LLMs in trying to get it to understand the relationship between a quantity and an object. For example, if you tell ChatGPT you have 24 apples, ChatGPT seems to have a hard time, or at least an inconsistent time, understanding that the object that you have 24 copies of is apple. There is more or less, evidence because of this showing that ChatGPT have a hard time with quantitative reasoning. But it is not just a problem strictly associated with the quantitative element. ChatGPT also has a hard time with logical deductions. I haven't played chess with ChatGPT, but I've heard that it is awful at it. What I have tried to do is use ChatGPT to help with my problem sheets at uni. What I found is that while ChatGPT knows every relevant definition and every theorem to a math problem, it cannot reason through them and solve the problem. If you push it too hard, in fact, it will get confused and give you rubbish like pi is odd or natural numbers are uncountable. This weakness of ChatGPT, while initially shocking, has a somewhat reasonable explanation. LLMs and possibly even the transformer architecture that they're built out of are not designed to perform quantitative or logical tasks. They're designed to understand text. The whole attention mechanism, from my very limited understanding, is designed to capture how different parts of text relate to each other. The architecture for LLM in both encoding and decoding, so the parts in understanding input and generating output, are very focused on handling text and not so much on performing reasoning or deduction. So this is one explanation, right? Another one that I want to throw out there, just because it also inflates my ego, is that math is just harder than everything else. And there is some truth in this in regards to what I said earlier about ChatGPT knowing the relevant theorems and definitions. In math, just because you know all the relevant knowledge doesn't mean you can draw the right conclusion. And I know that this is somewhat true universally, but it is especially the case for math, which means it is more difficult to LLMs to excel in math-related tasks because their strengths of knowledge is a little bit less relevant. On this matter, the last thing that I will say is that there are definitely some research going into this field. There was a paper where apparently ChatGPT was prompted to do very well in the MIT math curriculum. However, the paper, I think, has been retracted, or at least is removed from arXiv, so I don't know the details. Moreover, there is research into similar but different models for math. For example, Lean from Microsoft. A lot of people, apparently including Terry Tao, seems to believe that in the maybe next decade or so, AI will be able to significantly help in mathematical research, if not completely replacing mathematicians. Contrary to the disappointing results of LLMs in quantitative reasoning, textual reasoning seems to be something that LLMs shine in. My internship was to find out what companies are prioritizing from their annual reports. I was able to use GPT 3.5 to output some very, very strong results. This shows that LLMs, at least potentially, are capable of digesting relevant textual data and reason through them to draw useful conclusions. However, it is worth noting that a lot of my results weren't good as well. I had plenty of outputs that are what my supervisor would call standard corporate BS with no substance. And I think this inherent instability and randomness is one of the more unfortunate properties of LLMs. Next, on to CoGeneration. I started playing around with this myself, and one of the teams that I've talked to is developing something in this field. The result is pretty impressive. Not perfect, but impressive. I haven't tried using ChatGPT to solve any complex problems that you could find on LeetCode, for example, but plenty of people have, and they all seem to think that ChatGPT is a better developer than most humans, if not all. I have used ChatGPT to prototype web applications, and it is so convenient that I don't know why I spent last summer learning how to make front end. It is also interesting to hypothesize what this could mean for the industry. The CEO of Stable Diffusion seems to think that there will be no programmers in 5 years, and I think this might be a little bit extreme, but could also not be that far off. There are two factors I think that needs to be considered here. The first is more obvious. Low-level developers will just simply no longer be needed. Everything that they can do, ChatGPT can do faster and virtually for free. So those courses that guarantees that you can start with zero coding experience and get a six-figure developer's job in 4 months probably won't work anymore, if they ever did. However, this isn't bad news for the industry. In fact, the developers that offers more than writing simple code and can embrace like these new technologies like LLM will likely prosper from this. In China, we consider coding to be analogous to farming. If your skill set is just making buttons on a website, then yes, you will be replaced by automation just like many farmers were. But if you understand the theory behind creating buttons, the tech stack around it, the purpose of these buttons, and you can use prompt engineering to help you make buttons faster and better, then you'll do great. You will be the farmer that drives the big machine and earn a lot more than you would have otherwise been able to. The second effect of LLM is a bit more indirect, but I have heard from a few sources now that the tech industry is anticipating a fundamental change in the way services are structured. The more extreme and easier to understand conjecture is that in the future, instead of apps and applications and websites, there will just be one interface, and that is ChatGPT. You ask ChatGPT to, for example, book you a cab, and in the back, it will go and find whatever app is available, Uber, Lyft, doesn't matter, and book the cab for you. You don't need to actually access Uber or Lyft yourself. Now, it is important to note that whether this will happen and what the time horizon of this will look like is only speculation at this point. Lastly, my favorite use case for LLMs is using it to process textual data. It is hard to appreciate why this may be useful at first, but for a data analyst, this is incredible. Data analysis has been tied with automations and programming for decades now, because through the use of software and techniques, it is possible to process large amounts of structured data, like numbers and dates. However, unstructured data, like text, has always been a pain for data analysts to address. Even simple tasks like turning plain text with significant pattern into, say, a JSON file was pretty much impossible. Now it is as easy as connecting to LLM and writing a simple instruction, maybe provide an example or two. The convenience of this really cannot be overemphasized. What are some key things to remember when doing prompt engineering? First and foremost, you need to remember that prompt engineering is still essentially a machine learning technique, which means data is the most important thing. If you have an external knowledge base, you need to make sure that the information in there can actually be used to complete whatever task you want the LLM to complete. Or you need to give LLM access to the internet or other sources to extract the relevant information. Next, if you're using few-shot examples, then make sure your examples are actually relevant and representative. If you want an LLM to create you an investment thesis of a long, then don't give it examples of a short, or at least make sure you have enough examples of longs before you do that. And it is best to try to explain through the example to the best of your ability, because the paper on chain of thought prompting has shown that this greatly enhances performance. Lastly, I would say it is important to remember that LLMs are inherently somewhat random. So be patient and test any pipeline more than once. Just because a single output is good or bad doesn't mean the pipeline itself is good or bad. To conclude this video, I would encourage everyone, regardless of your major, your future career plan, to give prompt engineering a try. Even if it's just playing around with UIs like ChatGPT or Bing's AI chatbot. While I remain doubtful still that LLMs are as revolutionary as some people make it out to be, I have seen enough to believe that LLMs are the most powerful and easiest to use tool to have been invented for a while now. I think in the future, it may become something like Microsoft Office, where everyone, no matter what you do for a living, will use it regularly. So I think it is definitely a good idea to give it a try now.